Hello, I'm Chris McCarthy from the American Chemical Society. Welcome to this news briefing from the ACS Fall 2020 Virtual Meeting and Expo. We're joined today by Dr. Ramaswamy Nagarajan from the University of Massachusetts. He's studying how to make safer, more comfortable uniforms for soldiers. Dr. Nagarajan?
Thank you very much for the opportunity. Good morning. The fabric we use in everyday life is becoming increasingly multifunctional, and there's always a requirement having combinations of properties. So we have come up with a very easy approach to convert fabric to be multifunctional. The combination of properties which we will see is fire retardance and insect repellency. So here you see me holding a fabric. It's a fabric which is used for military clothing, combination of nylon and cotton, where we have treated them with a bio-based fire retardant material called phytic acid, and also using plasma deposition, having a coating for insect repellency. A student is actually setting it on flame, and you see that it doesn't really catch flame. It just causes char, but it doesn't really burn. So here's Sourabh Kulkarni demonstrating this, and essentially a very simple way of converting fabric, which is normally very flammable, into fire retardant fabric, and also having the ability to repel insects. So we do incorporate insect repellent in that. The combination of properties makes it multifunctional. The US soldier currently today is using fabric which is not even made in the US. Some of the fire retardants are too toxic to be produced here, so it's done in Europe. And the combination of properties are required for their safety. And these flame retardants are useful for everybody in common day life. So it's like, this is multifunctional aspect of it is for dual use, not only for soldiers, for firemen, for first responders, and everybody else.
Great, thank you. So are there any questions from our viewers? Please state your name and affiliation in the chat window when you ask your questions. So I'll start with, will this new fabric retain its flame retardant and insect repellent properties through repeated washings, or would the fabric need to be retreated from time to time?
It's an excellent question. So currently the insect repellency is such that we use a plasma-based deposition method. It is durable, so it can retain its insect repellency for almost 50 washes. The fire retardancy, although the chemically functionalized flame retardant is not really leached out, it is equivalently attached to the fabric. It seems to have some problem after 10 washes. I think it's chelating some other ingredient, and it's not as fire resistant. So we are on the process of actually developing methods to increase its FI characteristics for beyond the 10-15 washes. The military requirement is 50 washes, and rather high temperature and a strong brace. And we will get to it eventually, I guess.
Great, thank you. And why would you want to add microbial compounds to the fabric, and have you tried doing this yet?
So currently, this is what we have done is anti-insect repellent compounds, and mainly for mosquitoes and things like that. And the compound we're using is permethrin. It's plasma deposited onto the surface. We are also increasingly looking at antimicrobials. Multifunctionality is one of the big themes overall for fabric now, because as you know, even the fabric we wear, we want different properties, whether it's fire retardancy or non-stick, or super omniphobicity, or insect repellency, antibacterial. So the chemistry which we have outlined in this particular approach is sort of generic. You hang off certain functional groups on the surface of the fabric, which can be further functionalized with, let's say, an antimicrobial agent. So it's easily adaptable to other types of functionalization.
Thank you. Do you think your method would work for pure cotton or cotton blends that are other than nylon cotton?
It's an excellent question. Actually, most of the chemistry which we have doing is actually going only to the cotton phase. So it works very well for cotton. For nylon, we do have different chemistries which we're developing. It's much more difficult material to fire retard. As you know, nylon products catch fire beautifully and burn beautifully too. It's more of a challenge to make it fire retardant. The fabric you saw on the video is 50% nylon and 50% cotton. So all the fire retardants are actually functionalized on the cotton phase currently.
Great, thank you. Are there applications for this technology beyond soldiers' uniforms? I know you mentioned first responders, but could this be something for maybe hikers or more commercial use?
Absolutely. We are looking at this as a possibility for dual use, mainly for tents and other applications where you don't want fire. So it's primarily the two things we consider as safety. So make sure that the compounds we are using are safe, not the compounds which we are trying to replace, the halogenated ones. Second thing is the process should be rather easy to do, so it's cheap enough so the fabric is eventually going to be filled in a way it's not adding too much to the cost. The third aspect, of course, is breathability. It should not really adversely affect any of the properties of the fabric. It should be breathable, especially if it's something which people wear. And the mechanical characteristics are not changed in any way.
Thank you. Have you tried making this fabric into a garment yet? And if so, was it comfortable to wear for long periods of time?
No, not yet, but we have done breathability studies. The treatment processes do not adversely affect the breathability, and it does feel like a fabric. It doesn't feel like paper, so it is drapable. So yes, we have not made a real garment with it, but we are very confident that it can actually be made into a garment.
Great. So you mentioned safety. Do you know if the modifications to the fabric trigger any allergic skin reactions?
As of now, we have not done any allergy studies on it, but the compounds which we are using are bio-derived waste food product, which we are using as a starting ingredient. The insect repellent which you're using is currently being used by the military and other places, and the only thing is the method is locking it down on the surface such that it can be laundered 50 times and it still doesn't leave. And it just still retains the insect repellent property.
Great. So are there plans for the Army to test the fabric on actual soldiers?
Yes, we are heading in that direction. Once we actually qualify the durability beyond the 50 washes for the fire retardants, we work very closely with the Army as Combat Capabilities Development Command in Natick, Massachusetts. And they are part of this paper. In fact, they are very much technically involved in this discovery as well.
So what compounds other than the phytic acid could you try adding to the fabric to improve its flame retardant properties?
So the nylon phase, we know for a fact works very well. If there are compounds like tannic acid works very well for the nylon phase. There's some sort of a selectivity. So we are also addressing the nylon phase as we move forward, not only the cotton phase. The phosphorylation chemistry is very well known for cotton. So a lot of phosphorus-based compounds can be functionalized onto cotton. And it allows to build a char layer. Char is good. It suffocates the fabric from oxygen, and that's how the flame retardant works. It also modifies the way the decomposition happens. There are numerous phosphorus-containing compounds which can be used. We like the phytic acid because it's a waste product, a food product, which can be utilized very effectively in this case.
Wonderful. So what are the next steps for this research?
Addressing the durability issue, the first one, being able to go beyond the 10, 15 washes we have right now to about 50 washes. The skin, the toxicity studies, whether it is causing any irritation or anything to the skin is another one. We know for the fact that insect repellent compound is not really not causing any problems to the wearer, but the fire retardant compound should also be analyzed for that. And then, of course, in general, making sure that it's durable and comfortable and wear and breathable and doesn't have any mechanical property changes. That we have verified to a large extent. And you asked me the question whether it can be made into a garment. That's something we should do. More and more, if you look at the Army fabric, they have a lot of other requirements. They print a camouflage. They want a particular signature, and those are the properties which we need to also address and satisfy for this fabric before it gets implemented in the field.
Thank you. Could you comment a little bit more about the green aspect of the material you developed?
The fundamental reason why we are doing this is to replace some of the toxic compounds which are used currently for flame retardants. They are either added in the spin dope itself for the fiber forming in the fiber forming process, or they use regenerated cellulose, which is again produced in a very difficult process and not environmentally friendly process. You're taking cotton and nylon, which is prepared as is, and seeing if there is a coating-based approach which we can use to address the same problem. The compounds we are using are bio-derived and safe and food byproducts, and we want to be sticking to those options. In the insect repellents as well, we are looking at other compounds which are naturally derived, which are non-toxic, to see lesser toxicity than even what we are using. Currently, we're using permethrin. So, and to see if there are other options which are non-toxic for this.
Thank you. Do you have any closing thoughts for our audience?
I think multifunctionality is going to be the big thing as we move forward on not just fabric, any material we're using, and being able to adapt the surfaces of fabric and other materials to functionalize the various types of ingredients that you get multifunctionality is going to be something which is very, very important moving forward. This particular demonstration is showing that it is imparting at least two functionalities, which is flame retardants and insect repellents. But we can basically amplify these into other like antibacterial and antiviral, because it's a very important thing as we are moving forward in this COVID times. But antiviral characteristics is a very good one to have as well. So multifunctionality is the theme which we want to see, and green chemistry, of course. And do it in a way it's safe and it's not a regrettable substitution afterwards.
Thank you so much.
Thank you so much.
The archived version of this session will soon be posted at www.acs.org/fall 2020 press conferences. And please join us for our next press conference at 1 p.m. Eastern Time today on how sour beer gets so sour. Thank you.
Thank you very much.